Okay, lesson 5, modeling with systems of equations. So we've been working with systems of equations for 4 lessons now, and now we're going to really move into word problems or real world situations here. So what I want you to do is I have 2 links here for you to start with today. One is the warm-up. That's going to go out to Microsoft Forms. Go ahead and complete that. Second is a video I want you to watch on your own. Watch this video, truly take in what they're discussing, then come back to my video and we will continue on with the lesson. Okay, so here are some real world scenarios that can be modeled using system of equations. First one, we've got Jonathan who has 9 bills in his wallet, so that's important. He has 9 bills in his wallet and he has either $5 bills or $10 bills. So first they want us to think about this and try to fill out our table. If he has 9 total bills and he has 0 $5 bills, that means he must have 9 $10 bills. How much money does he have? Well, 9 times 10 is 90. If he has 1 $5 bill and he has 9 total bills, it means he must have 8 $10 bills. What would that look like? Well, he has 1 $5 bill plus 8 $10 bills. He has $85. Okay, fill out the next 2 in the table. If he has 2 $5 bills, he must have 7 $10 bills. What would that look like? 2 times 5 plus 7 times 10, which is 80. And then 3 $5 bills means 6 $10 bills. So 3 times 5 plus 6 times 10 is 75. So the question says, if F represents the number of $5 bills and T represents the number of $10 bills, then what does the following expression calculate? So right here, what would you say this stands for if you were to read it out loud to somebody and express it in words? I see 5 times F. What's F stand for? Number of $5 bills plus 10 times number of $10 bills. And what does that expression give us? How much money he has. Okay, so they basically have helped us out pretty well here, giving us this first expression because it's going to help us create our first equation. So we could actually bring down that first expression, 5F plus 10T. Going to set it equal to something. Think about what we would set that equal to. We know that we've been working with system of equations, so we know we must have 2 equations, so we're still missing one. Let's read what they have given us. Jonathan has a total of $55. We put that here. What I will say to you when you work with these word problems is money, money, money. This is $5, $10, $55. I put all the money in one equation. We still need another equation, and it has to do with this very last thing. Remember, he has 9 total bills. What were we doing up here in the table? We were adding these 2 to make sure he had 9. 1 plus 8 gave us 9. 2 plus 7 gave us 9. So we were taking F and T and adding them together to make sure we had 9. So F and T, make sure we have 9. So now that we have learned elimination in our last lesson, we will use that here to finish solving this equation. Remember, parentheses around both. Take the numbers and exchange them. The 5 goes up, the 1 goes down. Everything in the first expression gets multiplied by 5. So that becomes 5f plus 5t equals 45. 1 times everything does nothing, so this equation stays the same. 5f plus 10t equals 55. Line subtract. First term always gets crossed out. 5 minus 10 is negative 5. 45 minus 55 is negative 10. Divide both sides by negative 5. How many $10 bills does he have? 2. Well, how many $5 bills would he have? How many total bills does he have? 9. If he has 2 $10 bills up here, how many? Oh, we don't have 10s though, but opposite, we have 7 $5 bills. So that's the answer for this system. Now they say, what if we change the whole problem and say now he has 7 bills, and this time they're 5s and 20s. He has a total of $120. Set up the system of equations. So think about this. It's not much different than our 2 equations above. Here he had 9 total bills. We did f plus t equals 9. Here he has 7 bills. So f plus t equals 7. This equation, he had $5 bills and $10 bills and had a total of $55. This time we have $5 bills, $20 bills, and a total of $120. Go ahead and set up that second equation. So he has $5 bills and $20 bills and has a total of $120. Okay, go ahead and solve. You can pause the video, solve this part, and then come back and watch me solve it. Okay, solving this. Parentheses around both. 5 goes up, 1 goes down. Everything gets multiplied by 5. 5f plus 5t equals 35. This one, everything multiplied by 1, doesn't change it. Subtract, cross out. 5 minus 20, negative 15. 35 minus 120, negative 85. Divide by negative 15, divide by negative 15. What do we get? What do we get? Actual repeating number. So, set up and solve to help evaluate whether we could have been told true information. Can we have 5.6 $20 bills? Is that possible? No. We were not given true information. So there's your first example of a real-world situation involving money. Now let's go to another situation. This one they love to do on Regencies, talking about buying things and spending this much. A lot of times they'll do it with restaurants or fast food, or here's at the movie theater. So look at this one. We got Samantha and Raza, and they both went to this concession stand. Now Samantha, here's Samantha. She bought 3 pretzels, 4 sodas, paid $11.25. Raza went to the same one, bought 5 pretzels, 2 sodas, paid $8.25. First question says, before you start setting up the formulas, what if we say pretzels cost $1.75 and sodas cost $1.50? Is this right? Well, let's think about Sam. Sam bought she brought 3 pretzels. So Sam bought 3 pretzels, and pretzels are $1.75. She also bought how many sodas? 4 sodas. Now Raza, she bought 5 pretzels and 2 sodas. It says that Sam spent $11.25. Go ahead, do the math for Sam that we have here. Go ahead and simplify this. See if you get $11.25. See if they're correct. So you should have got $11.25. So it worked. This one's true. What about Raza? Have you simplified that one? See what we get for Raza. It says that she spent $8.25. See if you get $8.25. So I get $11.75, which we're supposed to get $8.25. So it's false. So we don't have the solution then. The solution is not $1.75 for pretzels or $1.50 for sodas. So we're going to now create our own equations to solve for the cost of a pretzel and a cost of a soda. They say X is going to be pretzel and Y is going to be soda. So let's read the sentence again. Sam went to a concession stand and bought 3 pretzels. 3 pretzels. And she bought 4 sodas and spent $11.25. So literally you pull all this information right out of the word problem in order. Go ahead and do Raza now. Write her equation right underneath. Right underneath. So Raza went to the same stand and bought 5 pretzels and 2 sodas and spent $8.25. That's the equation you should have wrote. Okay, now go ahead to part C they want us to solve. So I'm going to rewrite the equations down here. And go ahead, pause the video and solve these 2 equations and come back when you're done. Okay, compare your work to mine. So I got a Y, which stands for sodas, at $2.25. Now I need to figure out what the pretzels would cost. So I'm going to pick one of the equations above like we've done before. I'm just going to go with this one. Sure, 3x plus 4y equals 11.25. I'm going to plug in my y. So 3x plus 4 times 2.25 is 9. Minus 9, that gives me what? 225. and divide it by 3, and that gives me 75 cents. So there it is. Pretzels cost 75, soda costs $2.25. If Leah went to the same concession stand and bought 2 sodas, we know 2 sodas cost $2.25. So there's 2 sodas. How many pretzels would she need to buy so that she spent the same amount? So I put this equal sign for same amount. How many pretzels, well that's X. How much are the pretzels? 0.75. Would she have to buy to spend the same amount? So go ahead and solve that equation. Pause the video and solve the equation. So if I multiply, it's 450. Divide, and it's 6. Okay, last question for the notes. We can also use systems for geometric equations. They love the rectangles, so you will see this often on the regions too. Guaranteed you're going to see one or the other on a region. So here we go. We have a rectangle. Whenever I go with the rectangle question, I love to draw a diagram to help me put all the information down. So it has a perimeter, I'm going to put that in the inside as a P, of 204 feet. Its length is 6 feet longer than twice its width. Put a W for width. So now I've got my diagram labeled. So 6 feet longer than twice its width in perimeter. Now, to set up my equation or my systems, I need to know what in the world perimeter means. So what does perimeter mean? Think about it. So perimeter is the distance around the rectangle. So what would be the 2 equations I could use? Well, I see one already, right here. L equals 6 plus 2W. First one done. What I'm missing is perimeter. The perimeter equals 204. What is the equation for a perimeter of a rectangle? If you're adding up all around the outside, how many lengths are you adding up? 2. How many widths are you adding up? 2. So there is the formula for a perimeter equation for a rectangle. Would I use elimination here? Does it look like an elimination problem where I could do double parentheses, switch? Doesn't look like what we've been doing in the notes, but it does look like a substitution. Go ahead, pause the video, solve this problem using substitution. Okay, so here it is. I see an L equals. All of this is going into L. What's it look like? 2, 6 plus 2W plus 2W equals 204. Distribute. 12 plus 4W plus 2W equals 204. Combine like terms. 6W. SADMAP, get rid of the 12 first. 6W equals 192. Divide by 6. W equals 32. Not done. We now only have the W. We need to find the length. Well, the formula for length was 6 plus 2W. So we can plug in the W of 32. Oh, that's an equal sign there. And get 70 with length. Okay, go ahead, click on the Con Practice. Try a couple examples. If you don't know what you're doing, right below the example it says use a hint or show me a video. Take advantage of these things to help you solve the problem. When you're done with the con practice, if you still have more time, I have more practice here. They're not word problems, it's just back to systems, practicing when do I use elimination, when do I use substitution, when do I maybe graph. Maybe I find it easier to graph to use a system of equations. So you take the rest of your time to complete the rest of this.